Okay, so particle A hits particle B, M, 3M, and then M, 3M. Draw the before and after picture. This one's going in with speed U. This one has no speed whatsoever. So U2 equals 0. This one is, we don't know the speed after its collision. And phi2, we don't know its speed after collision. We're assuming they're all going to the right. If they aren't going to the right, they're a negative sign and they're going left. Right, start with conservation of momentum. M1U1 plus M2U2 equals M1V1 plus M2V2. Please stay on top of me if I write a 4 instead of a U, okay? So, we're going to get MU plus 0, because U2 is 0. Then we're going to get MV1. And then we're going to get 3MV2. We're then going to get V1 plus V2 equals U. 3V2, thank you. V1 plus 3V2 equals U. Is that alright? Okay. I think this is 2009, is it? Sorry? Oh, is it? Okay. Now, what we get next is this, guys. We're going to get we're going to try NEL, Newton's experimental law, where in Newton's experimental law, phi1 minus phi2 is minus E U1 minus U2. Okay, so phi1 minus phi2, anybody? Is minus E times U. So phi1 minus phi2 is equal to minus EU. Add them directly downwards, but multiply the bottom one by 3. V1 plus 3 V2 equals U. 3V1 minus 3V2 equals minus 3 EU. Go directly down. 4V1 equals U minus 3 EU. Bring down the 4, yeah? And then what we're going to get is divided by 4. And we get that there. Now, I don't know about you guys, but I find I'm a lot quicker when I don't do the substitution. When I actually just solve it again from scratch, I actually tend to go a lot faster than substituting it in. So what I do back here is I go all the way back up here, and what I do instead is, instead of getting rid of V1, I'm going to get rid of V2. So I'm going to multiply by minus 3 instead of plus 3. So what I get is V1 plus 3 V2 equals U. Get minus 3 V1. Oh, wait a second. Getting rid of V1, I'm going to just multiply by minus 1. Multiply by minus 1 and we get minus V1 plus V2 equals EU. Therefore 4 V2 ends up to be U plus EU. Factorize the top and then divide by 4. And there's your phi1 and phi2. Is that okay with you guys? phi1 and phi2. Now, part 1 is done. If E equals a quarter, find the percentage loss in kinetic energy due to the collision. Okay, so if E equals a quarter, all we have to do is this. E equals a quarter. So what we can do is we can say that phi2 is now going to be U1 plus a quarter all over 4. Phi1 equals U into 1 minus 3 quarters over 4. What they're going to be is, one of them's going to be phi2 is going to be 5U over 16 when you use the calculator, and phi1 is going to be U over 16. Now, loss in kinetic energy, loss in KE, loss in kinetic energy equals KE before minus KE after. Okay, so KE before minus KE after. So I'm just going to get my KE before and my KE after. In the before picture, guys, okay, one of the particles wasn't moving, but the smaller particle m was moving with u, and the 3m particle wasn't moving at all. So what we're just going to get for k before is a half mu squared. The ke after picture is completely different. We have this, the v1 is going to be u over 16 to the right, and the v2 is going to be 5u over 16 going to the right. So we're going to have a half m times something squared plus a half 3m times your speed squared, because there's two different particles moving. So the two particles are going to be u over 16, and this is going to be 5u over 16. Going to put them both into the calculator, and what I'm going to get is 19 mu squared over 128. Now my loss in kinetic energy is going to be a half mu squared minus 19 mu squared over 128, and what we're going to get there is 45 mu squared over 128. Okay, we're asked for percentage loss. Percentage loss equals loss over original amount multiplied by 100, which in turn is going to be 45. Awesome. We're going to do this. We're going to the loss was 45 mu squared over 128. Our original amount was a half mu squared. We're going to multiply that by 100. All I'm going to do in the calculator, guys, is just going to ignore the mu squared. I'm just going to put 45 over 128 divided by a half, multiply it by 100, and what we're going to get there is a loss of 70.3%. It's a big loss because the E value is small. If the E value was 3/4, you'd have a much less loss, because remember, E value refers to that if you throw a ball against a stationary ground, E equals a quarter means it'll only rise to a quarter of its old height. It only retains a quarter of its kinetic energy. Alright? Okay. So that's 55. Now part B. A smooth sphere of mass m moving with velocity 6i plus 2j collides with a smooth sphere of mass km moving with velocity 2i plus 4j on a horizontal table. After the collisions, the spheres move in parallel directions. Find the coefficient of restitution. The coefficient is e. Find the e in terms of k, and then prove that k is greater than a third. So here's what we're going to do. Before and after picture again. Then we go down. After picture. Okay, are they both equal mass? No, they're not. M and Km. M and Km. Okay, next thing. Draw their speeds in. This one's going 6 across, 2 up. The other one has an initial velocity of 2 across and 4 up. Now, after the collision takes place along what axis? What's the axis the collision takes place on? The x-axis. So what speed is affected? The 6 and the 2 are going to be affected. They are going to turn into v1 and v2. However, the vertical speeds completely unaffected. Okay, so they're still that one. Now we're going to do PCM. M1U1 plus M2U2 equals M1 V1 plus M2 V2. But we're only going to do it along the x-axis. We're not going to do it the components. We're only going to take these parts here. So it's going to be M in there as well, isn't there? So it's going to be 6 times M times 6 plus Km times 2 equals M times V1 plus Km times V2. I'm going to divide by M, so I'm going to get V1 plus KV2 ends up to be 6 plus 2K. Everybody happy enough with that? Okay, I'm now going to do NEL. So Newton's experimental law, guys. Uh, with here, I cancel off the amps, and then I just change sides. Okay. So phi1 minus phi2 equals minus E times U1 minus U2. That's what we're looking at here. Okay, phi1 minus phi2 is the same. E stays the same, but the speeds aren't. It's 6 minus 2, such that phi1 minus phi2 equals minus 4e. Now, I'm going to have to just reread it. Coefficients, they move in parallel directions. I'm probably going to need phi1 and phi2. Which one's the easier one to get? Phi1 or phi2? Phi2, because I can just multiply this one by minus 1. Minus phi1 minus k phi2 equals minus 6 minus 2k. I'm then going to find out that it's minus, these cancel, minus phi2 minus k v2 equals minus 4e minus 6 minus 2k. It has 3 different parts to it, okay? Multiply both sides by minus. Just takes a lot of concentration. And then factorize and bring it down. Phi2 into 1 plus k. So phi2 equals 4e plus 6 plus 2k all over. What is it then? All over 1 plus k. Now, if you think I'm subbing that in, you're crazy. I'm not subbing that in. Okay? So I'm going to do it again from scratch. So I have phi1 minus phi2 equals minus 4e. And the second equation was, what was it? Phi1 plus kv2 equals 6 plus 2k. That was from up there. Any ideas on how to solve that? Sorry? Multiply the top one by k. Multiply the top one by k. So you get a kv1 minus kv2 equals minus 4 ke divided by phi1 plus kv2, and then on the bottom we just get 6 plus 2k. Cancel. So we're going to get phi1 into 1 plus k. I added them together and I factorized them in one go. Cancel the two of them. Then I get 6 plus 2k minus 4ke. Go and divide it by the 1 plus k. 6 plus 2k minus 4ke all over 1 plus k. So there is my phi1 and my phi2. Now, here's the interesting parts, okay? I'll just get rid of all this for a minute. All this is now useless. Now, back to the top. This is the picture I need to look at. Okay, it says they're parallel after the collision, doesn't it? What does that mean, they're parallel? What does that mean in regards to ratios? Like, two objects that are parallel could be something like this. One object moves 10 across and 5 across and 10 up. An object that's parallel to that would be one that goes 4 up and 2 across. What do they have in common? That 10 over 5 is the same thing as 4 over 2. What I suggest is that we do a similar process. That one of them over the other one is they're equal to each other. Okay, so what I'm going to do is this. I'm going to say that, and do we know anything about their speeds? 2 phi1. Yeah, we got this. 2 over phi1 equals 4 over phi2. So, 2 divided by this big fraction here equals 4. Wait. I got them mixed up, did I? Go again. 6 plus 2k minus 4ke all over 1 plus k. And then the other side is going to be 4 divided by 4e plus 6 plus 2k all over 1 plus k. What can we do with the fractions on the bottom, guys? What can we do with this here? Bring it up and turn it upside down, right? So turn it upside down. 6 plus 2k minus 4ke. And then the other one, bring that up to the top and turn it upside down. 4 times 1 plus k into 4e plus 6 plus 2k. Now guys, what can we cancel? Everybody cool with that? Now, here's what we're going to get. It's basically, when we do that, it basically turns out to be this. It's this one here over 1 equals 2 times that one there. And that top turns into a 1 as well. I'm going to cross multiply. So I'm going to get 4e plus 6 plus 2k equals 2 times that, which is going to be 12 plus 4k. What's that going to be? Minus, sorry? Is it going to be 8ke? Minus 8ke. Okay. Nearly there. So, what I'm going to do is bring everything that has a k onto one side and everything that hasn't got a k to the other side. So let me bring the 12 over here and bring the k's over here and the e at the same. No, leave the e where it is. So 4e minus 6. Everybody happy with minus 6? 6 minus 12 minus 6. Then I'm going to get 6k minus 8ke. Factorize, divide everything by 2, yeah? Huh? Yes, 2k on the right hand side, sorry. Well done. 2k on the right hand side. Divide everything by 2. Factorize out k. Divide the k underneath, or the 1 minus 4e underneath. Oh, sorry, I'm finding e on its own or k on its own? Ah, e on its own. Excuse me. Nearly there. Instead of finding k on its own, I'm going to put the e's onto one side. So it's 2e plus 4ke equals k plus 3. Factorize out 2e. 2e into, what's it, 1 plus 2k equals k plus 3. Actually, I shouldn't have factorized out to 2 at all. Go again. E into, yeah, we got it now. E into 2 plus 4k into k plus 3. E equals k plus 3 into 2 plus 4k. Thank God, that was a bit of a battle, okay? Now, prove that k is bigger than or equal to a third. What's the rule for e? E always has to be smaller than 1. So k plus 3, 2 plus 4k is less than or equal to 1. K plus 3 is smaller or equal to 2 plus 4k. Minus 3k, bring that over this way, is less than or equal to minus 1. Therefore multiply both sides by minus 1. 3k 2009. So guys, what we have here is this, 3k is greater than or equal to 1, k greater than or equal to 1/3. Okay,